Okay, to start this video, we're going to talk about this problem here. So we have 18 to the 4 minus 6a plus 3 is equal to 91. Okay, and the important thing we need to know is before we can use the log snail, we need to get the exponent by itself. Okay, so just like if we had something like this, well, before we can square root this, we have to subtract 2 over, and then get x squared is equal to 4, divide, and we get x is equal to plus or minus 2. Okay, this is the same idea. So before we can do the log snail, we need to subtract this 3 over. So subtract it over. Okay, so this gives me 18 to the 4 minus 6a is equal to 88. Okay, now we look at our bases. Our bases aren't the same, and in this case, we can't make them the same using exponent rules, so now we use our log snail. Remember, we're going from an exponential to a log, so we start with writing a log down here. Okay, we always start with our base, which is 18. Put our base right there, and then we make our snail. So we go here to this one, and then to this one. Okay, so we already have our base down there. So then we follow, we get to 88, so that's our next one here. So put 88 inside here. And then we follow again down to this one. So we set it equal to 4 minus 6a. Okay, now we're solving for a, so we want to try to get a by itself. I'm going to start by subtracting 4 over. So now I have log of 18 of 88 minus 4 is equal to negative 6a. Remember, this is just a number, okay? Then I'm going to divide negative 6, divide by negative 6. So here I get the log 1888 minus 4 over negative 6 is equal to a. And there's my answer there. Okay, so the next thing we're going to talk about is log properties. Actually, even before that, we're going to talk about extraneous solutions really quick. Okay, so we're going to talk extraneous. Okay, so just like last unit, we need to watch out for things called extraneous solutions. Okay, and extraneous solutions happen for logs when we have a negative in our argument. Okay, so we cannot have log of a negative number. So say we had negative 4 like that, can't have it. That's an extraneous solution. Okay, so we can't have a negative. Okay, so the way we check this is, let's start with a problem. Okay, so say we just had something like this is equal to 4, okay? So this is an example. We're not going to solve this one, but we're going to talk about what would be an extraneous solution for this one, okay? So let's say we got the answer as x equal to 0. I don't know if that's the right solution for this problem, but we're just going to say what if. Okay, so say we got x is equal to 0. Well, if I go back and plug 0 in for x, I get log of 5 is 0 minus 1, which gives me log of 5 negative 1. Yikes, I can't have a negative in my argument. That means this x is equal to 0 is an extraneous solution. Okay, so that's extraneous solution for logs. And then natural log, there's just one added thing here. So a natural log cannot have a negative, right? So we can't have a negative, and we can't have the natural log of 0. So if whatever we get as an answer and we plug it back in and it gives us a negative or it gives us a 0 in the argument, it's an extraneous solution. We can't have it. Okay, so that's extraneous solutions. The next thing we're going to talk about is log properties. Log properties, okay. The first one is adding. So when I add logs and natural logs, so this goes for natural logs too. When I add them together, I multiply the arguments. Okay? And then when I subtract, I divide the arguments. Okay, so let's look at an example. So here we have natural log of 3 plus the natural log of x plus 5 is equal to 4. Okay, so when they have the same base, only when they have the same base. Okay, so when they have the same base and they're adding and subtracting, we can combine them. So here we know this is just the natural log of e, natural log of e. Well, they have the same base, they're adding, so that means I multiply my argument. So I combine into 1 and then multiply my arguments together. So I have 3 times my x plus 5, and then this is equal to 4. Okay, now I can carry out this multiplication. So I have the natural log of 3x plus 15 is equal to 4. Okay, then I solve this problem using my log snail. So I start with changing this to log of e of 3x plus 15 is equal to 4. Okay, always start with my base. I'm going from a log to an exponential. So I start with my base here. Then I make my snail. So the next one we come to is 4. So I put my 4 up here. Then if I follow it, I get to 3x plus 15. Okay, get x by itself. I'm going to subtract the 15 over first. So e to the 4 minus 15 is equal to 3x. And then to get x by itself, divide by 3. Divide by 3, we get e to the 4 minus 15 over 3 is equal to x. And there is my answer. Okay, so now let's look at a subtracting example. So let's try the log base 7, 9x plus 27 minus the log of 7 is equal to 2. Okay. So here we check if they have the same base. Same base, perfect. Okay. So now, since they have the same base, we're subtracting. Well, that means I combine them and divide the arguments. So I keep log of 7. Okay, and then I divide. So I have 9x plus 27 over 3 is equal to 2. Well, this one turns out to be nice. I can simplify these. So I get log of 7 of 3x plus 9 is equal to 2. Okay, do my log snail. So I have 7 here. So I start with 7, log snail. Here, 3x plus 9. Okay, this gives me 49 minus 9 is equal to 3x. Subtract these two and divide, I get 40 over 3 is equal to x. Okay. Now going back to both of these problems, there's one last step that we need to do. Okay? Need to check for extraneous solutions. So let's start with this last one first. Well, I need to know if I plug this number in to any of these, okay, or this one, if I get a negative in my argument, it's an extraneous solution. Here, if I plug this into here, I plug this into here, I don't get a negative, so I know we're all good. Okay, let's check this one. 40 over 3, if I plug this in right here, so I would get, let's see, 3 times 40 over 3 plus 9. I get 40 plus 9, I get 49. That's a positive number, which we can have. This is not extraneous solution, so we are good.